Hello, my dear students. Good morning to each one of you. Hope so you are fine and enjoying these digital classes nowadays. So, dear student, as you know, we are doing Unit 2, that is Structure of Atom. And welcome to digital classes. समय 10 से 12 वाला हर घर में पाठशाला. Today we are going to study about quantum mechanical model of atom and quantum set. So, as we have done our de Broglie equations and Heisenberg uncertainty principle. So this concept, quantum mechanical and model of an atom, it came from basically those two theories. As in these two theories, we have studied about how the nature of electrons are there in atom. As Bohr's model, limitation of Bohr's model were there. According to Bohr's model, the electrons are revolving around a fixed path. But according to de Broglie equation and Heisenberg uncertainty principle, electron is not revolving only, it revolving like a wave and continuously moving like a particle. Okay, that is according to dual behavior nature. And according to Heisenberg uncertainty principle, it is difficult, we cannot predict the velocity, movement or momentum of the electrons around the nucleus. So now, according to this quantum mechanical model of an atom, it is somewhere telling us about more clear structure, more clear picture of the atom. So very interesting topic and very important also. So dear students, please watch this video full. Definitely you will come to know about so many things. Okay, so let's start. The topic name is quantum mechanical model of an atom, in which quantum mean wave. The meaning of quantum is wave. Mechanical mean motion of any object. Okay, and if we are talking atom, so we will talk about the microscopic object, that is electron, proton and neutrons. So before going to study the definition of this, let's discuss about the mechanics. What is the meaning of mechanics? Mechanics word, as mechanical came from mechanics word, it is the study of motion of bodies. Study of motion of bodies. All those bodies which is continuously in motion, that is called mechanical models. So there are basically two type of mechanical models, classical and quantum. Classical mechanical model is talking about the macroscopic object, which we are studying in the physics, and we studied in the Newton's law of motion in 9th class also you have done. Whereas in quantum mechanical model mean microscopic object, which particularly we are studying in this topic, and it is given by Schrodinger equation, Schrodinger wave equation also. So let's discuss about the definition of quantum mechanical model. Quantum mechanical model of an atom is the picture of atom which emerges from the application of the Schrodinger equation of an atom. It is giving us a clear picture of atom, how the electrons are inside the atom, how it is moving, how its position, where is its position. Those all things we will discuss. So this can be discussed by applying this equation. This is a mathematical equation. Once we will put these equation, we will fill these equation. So mathematically we can calculate the exact position of electrons. Okay, so although in this class or in this especially in your syllabus there is no mathematical calculation, but we need to keep the equation only in mind. So what is the Schrodinger wave equation? According to this Schrodinger wave equation, this is a differentiation square psi upon differentiation x square plus differentiation square by upon differentiation y square, differentiation square psi upon dz square, you can say, plus 8 pi square m upon h square whole bracket e minus v psi is equal to 0. So let's understand what are these. Here differentiation square psi or dx square, whether this or this, these are representing the axis, like this is x-axis, this is y-axis, this is z-axis. As you know, dear students, three-dimensionally we have x square by y-axis and z-axis. So in an electron or in an atom, where the electron are lying, that we need to, that coordinates you have done in 10th class also. According to that coordinate we can find out the fixed position of electron. So what is the meaning of psi? Psi is wave function of electron, which is called Eiffel function also, and this x, y, z is the space coordinates along 3 dimensions, where m is the mass of electron, v is the total potential energy of electron, h is Planck's constant, and capital E is total energy of electron. So this equation, which is given by Schrodinger, this whole equation is automatically completely define the quantum is defining the quantum mechanical model of an atom. So by putting these values, we can calculate the exact position, although we don't have to calculate. So little bit more history. In 1926, Erwin Schrödinger, he developed an atomic model taking an account both the wave and particle nature of electron. By taking this wave and particle nature of electron, he find out he make a model, he develop a model. With the help of that model, we can calculate the exact position of electron. So this is known as quantum wave mechanical model. Why it is known as quantum wave mechanical model? Already I have explained. Quantum mean waves, motion of object and microscopic object. That's why. Or it is also known as quantum mechanics. Okay, in physics also you are studying. So it is the study of microscopic object motion, same. So let's discuss about the general feature and general characteristics of this. Very important. There are basically 5 properties, 5 characteristics. So one by one we'll discuss. Number 1, the energy of electron in an atom is quantized. Quantized mean we can write the number now as K, L, M, N, 1, 2, 3, 4. We are writing the value. So that is called quantized. It is also called certain specific values. Second, the quantized energy level are allowed solution of Schrödinger wave equation. Mean by putting this wave equation, we can find out the solution which allow us to quantize the energy level. Where is K shell, where is L shell, where is M shell, like this way. The path of electron in an atom can never be determined or known accurately as per Heisenberg uncertainty principle. This is the same like the uncertainty principle, but this concept has given us idea about atomic orbital. Atomic orbital mean nucleus is in the center and how the electrons are around the nucleus, that is called atomic orbital. So next is an atomic orbital is the wave function. So due to this psi, we can find out the atomic orbital mean the space between two orbitals and for an electron in an atom. Next and last, probability of finding an electron at a point with an atom is proportional to square of the wave function. When we are finding the probability of atom, although we don't know the fixed position of electron, but we can find out the probability very, you know very well the chances from where the electron is most probable finding, that is also called orbitals. So in orbitals, maximum chances are there to find electron. So that can be calculated by a psi square. It is called probability density, okay, which is always positive. So these are the 5 basic properties. Learn, understand and keep in your mind. So now discuss the basic concept. I am relating all the things. As dear student, in the beginning we studied the matter. Matter is which occupies space and have mass. Although basically John Dalton was the first scientist who told that atom is the basic unit that make any kind of matter. Mean all type of matter is made up of atom, which can neither created nor destroyed. It is the smallest particle. So after this, J.J. Thomson has given little bit model of atom by relating the Pulham-Pudham model with the help of watermelon model, in which he told electrons are embedded inside and proton are around that electrons. But although it was the wrong model, but at that time there was no advanced microscope. So that time people were satisfied with this model. But later on, so many limitations were there. Although the positive point was there, he told about the atom's neutrality as number of electron is equal to number of proton, and he discovered the electrons also. So second, Ernst Rutherford. In Ernst Rutherford, nucleus is in the center and electron revolve around the nucleus. So he proved the J.J. Thomson's model wrong, in which he said it is not electron which is embedded inside. There is nucleus in between. With the help of Goldfoil experiment, he explained, you know very well. So he discovered the nucleus. After that, his model was also got failed. And when the Bohr's model came, so Bohr has given more advanced model, as Bohr has quantized energy shell. He has distributed electron according to energy shell. So Niels Bohr's model was quite more modified, more stable, and he given the magic numbers 2, 8, 8, 18, 18, 32, 32 with the help of 2n square. So after this, now there was some limitation about Bohr's model also, as he hasn't told about the energy shell, the different orbitals. So this quantum mechanical model, now we are getting 2 things. Number 1, this quantum model shown us about the position of electron in atom and quantized system. So let's discuss in the next video about more about quantum set. Okay, so wait for the next video. Till then, you just go through once again this video and try to understand whatever things you are not getting. Please ask me, do ask me. Okay, till then, stay safe, stay home. Thank you. Have a nice day.